Salam and welcome everyone. So today we're going to be working on the question on the screen that says a laser used to read CDs emits red light of wavelength 700 nanometers. How many photons does it emit each second if its power is zero point 0.1 watts and if the power is 1.0 watts? So whenever I see a question like this, where you're asked to determine how many of something, you have to use your fundamental intelligence to be able to solve it. It is not necessarily just formula. Formula does play a big role in it, but in order for you to even bring up the formula, you have to use your skills of mental math or just think about it critically and logically. So now, they were told that the laser used to read CDs emits light of wavelength 700 nanometers. So the solution would be to first of all write out the parameters that were given. We're told the wavelength is 700 nanometers. How many photons does it emit? So we're asked to solve for the number of photons emitted each second. So the time is going to be 1 second if its power is 0.10 watts for the first question, and then the second question 1.0 watts. So I'm going to start with the first question, of course, and when we solve that, we can go on to the second question. So the power is simply 0.10 watts. So now we're now asked to basically solve the number of photons that is emitted each second at this particular wavelength. Now, what I meant by thinking critically is for us to remember that when we're told to find the number of something is always equal to the value of the total. Okay, in this case, the energy total or the total energy divided by the value of each individual photon energy or energy of photon divided by change in E, where ET is what you call total energy. Okay, and then change in E is just energy of each photon. So when we do this, we're going to be able to determine the number of photons. And that way you can think about it is, for example, say I have apples and each one of the apple weighs 5 kg, okay? And then the total weight of apple becomes 20 kg. In order for you to know how many apples I have, you would just say the number of apples would just simply be the total weight, so 20 kg divided by the weight of each individual apple, which is just 5 kg. So which should just be 5 kg. And when you do this, the math, you can see that all you have is four apples. So that is the same way we're going to think about it. It's so fundamental that it's the type of math you do in high school where you measure quantities by thinking of questions logically and coming up with a formula. So the number of photons is just simply the energy total or total energy divided by energy of each photon. Now that we want to determine how many number of photons, we have to first of all determine what is total energy in this question. The total energy in this question, when we go back to our question, we see we're told a laser used to receive these emits red light of wavelength 700 nanometers. How many photons does it emit each second if its power is 0.10 watts? Well, power times time, okay, is also equal to energy total. So power times time is simply the total energy divided by change in E, which is just simply the energy of each photon. And since we've been doing these questions in chapter 7 of the Atkins Physical Chemistry 11th edition textbook, that involve us studying quantum theory, quantum mechanics, quantum chemistry, you would notice that the energy of photon has always been Planck's constant times the frequency. So Planck's constant times frequency. So this is just going to be divided by h V. So that is basically the formula that we're supposed to use. But then we go back to our question. We see that we're lucky. We have successfully determined power, right? We can easily substitute that. We have time. Planck constant is a constant. So Planck's constant is just 6.626 times 10 raised to the power of negative 34 joule seconds. But we don't have wavelengths. But we need wavelength in order for us to solve for the unknown here. So to do that, we're going to use our very own knowledge of the fact that we can determine frequency when we've been given the wavelength. And the formula that I use to solve this is just simply C, okay, is equal to lambda times V, or C, speed of light, is equals to what? Wavelength times frequency. And frequency is just simply going to equal the speed of light divided by the wavelength. Speed of light divided by what? The wavelength. So N sub P will now equal P times T divided by H, and then the speed of light C divided by what? The wavelength. That is simply the situation here. So we'll just say N sub P, I'm going to rewrite the formula, is now going to equal PT divided by HC times lambda. Okay, so 1/1 over lambda will just be lambda, or I can just say PT lambda divided by HC is equal to NP. So this is the formula we're going to use, where the top of it divided by the divided by the denominator. So NP just involves us what? Simply substituting. We have here, the question says the power is 0.1 watts. So that would be 0.1 watt. Note again, watt, okay? Power, watt, is just simply has the unit or joules per second. So please, watt is also joules per second. I want to quickly say that because that is what I'm going to be substituting here. So that would be 0.10 watts is the same thing as 0.10 joule per second times time, which is 1 second, times lambda, which is just simply 700 times 10 raised to the power of negative 9 meters, divided by H, which is 6.626 times 10 raised to the power of negative 34 joule seconds, times C, which is just 2.998 times 10 raised to the power of 8 meter per second. So all of that, divide meters here, divide meters here, divide second here, divide second here, divide second here again, divide second here, divide joules here, divide joules here. We should expect that our final answer should please, 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 please not have any units, because we're dealing with the number of something. So the final answer would just be the number of photons, and then you put photons at the end of it. So we have 0.10 times 1 times 700 times 10 raised to the power of negative 9 as the numerator. We put that in our calculator, divided by 6.626 times 10 raised to the power of negative 34 times 2.998 times 10 raised to the power of 8. So when we do that, we end up getting 3.52383 times 10 raised to the power of 17. Okay, that is it. So these are the number of photons that we have in this question. We have 3.52383 times 10 raised to the power of 17 photons emitted, okay, each second. But then again, we're chemists, as you're very well aware. If you've been watching my channel, you're going to remember, or you have to remember, that we always put our work in the proper number of significant figures. And in this question, the proper number of significant figures is 2. Because when we go back to our question and we look at what we're using, we see that we're given 700 in 3 sig figs and 0.10 in 2 sig figs. So our final answer has to be in 2 sig figs. So NP, or the number of photons, ends up being 3.5 times 10 raised to the power of 17 photons emitted each second. So that is basically the answer to this question. Now that we're already done with this question, so we're going to be moving on to the second question, where the power is 1.0 watts. So I'm going to say the other power, okay, is 1.0 watts. And I'm not going to go into the detail of how, like, we, worked on the formula to get it. Just remember that the formula that we're going to be using to see the number of photons is just simply power, okay, times time, times lambda divided by Planck's constant times speed of light. So that is basically it. And if you want a quick refresher, even though I don't want to go into detail, let's not forget the main point of what I was trying to explain is that we're actually determining the number of each individual photon emitted each second if its power is 1.0 watts. In order for us to determine the number of something, we have to use the total quantity of something divided by the value of each individual quantity. That's how you know the total energy, in this case, divided by the number of the energy of each photon would give us the number of photons. When you do that, the total energy is just simply power times time. The energy of each photon is um, Planck's constant times frequency. We already know frequency is just simply speed of light divided by wavelength or lambda. We substitute it and we rearrange the equation for us to have the final equation to solve this, which is just NP or number of photons equal to power times time times lambda divided by HC. So knowing this, we can just simply substitute this to all of the values in this question. We already know power is just 1.0, okay? 1.0 watts is the same thing as 1.0 joule per second, okay? Times 1 second times lambda, which is just simply 700 times 10 raised to the power of negative 9 meters divided by h, which is just 6.626 times 10 raised to the power of negative 34, okay, joule second times 2.998 times 10 raised to the power of 8 meter per second. So that is basically all of this information substituted. We can just cancel out all of the units as we go through the calculation. So you cancel out the seconds here, cancel out the meters, cancel out another seconds here, cancel out the joules. We want our final units to be nothing because we're dealing with the number of something, right? We don't need a unit for that to be able to determine the quantity of something. So now we're just going to substitute the numerator and denominator in the calculator. 1.0 times 1 times 700 times 10 to the power of negative 9 divided by 6.626 times 10 to the power of negative 34 times 2.998 times 10 to the power of 8. When you input all of that information in the calculator, you end up getting 3.52383 times 10 raised to the power of 18 photons, okay, emitted at 700 nanometers wavelength. That is basically what's going on here. So we can simply put this work in the proper number of significant figures. We see that 1.0 watts is in two sig figs. So this final answer has to be in two sig figs. So the number of protons ends up becoming 3.5 times 10 raised to the power of 18, okay, photons emitted at 700 nanometers. So this is basically the answer to this question. If you have any suggestions, concerns, opinions, observations, make sure you put it in the comment section. I want to make sure I grow this channel in order for it to be like influential and impactful for students so that whatever struggles that you're having in physical chemistry and other STEM related courses, you feel comfortable that whenever you come here, you're going to be living better, much better than when you first got it. So that is my goal for this channel. So if you want to support me, please support me by subscribing and watching the videos, as well as telling me the suggestions of what you would like to learn and what you would like to gain from this channel. I also wanted to mention that if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or college, please do email me at yohabitutoring@gmail.com. I help students succeed in all their STEM related courses in order for them to succeed in academia by my way of tutoring and mentorship. So if you would like to book a session with me, email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.